Entity Relationship Diagram. Lessons 1.4 Transformation in ER Diagram. In these lessons, you will have a basic understanding in different methods of transformation, and you will know how to use transformations to generate alternative designs. This is the scenario for you to study. You should read the scenario before of the lessons, and the scenarios have already uploaded to the system. According to the scenario, these 5 possible entities will be generated. They are customer, meter, reading, bill, and rate. And according to the case, this possible ER diagram was generated. However, the ER diagram you generate in the first time may not be the perfect. Therefore, you need to refine your ER diagram. After you construct the initial ER diagram, you have to revise many times, and then to generate feasible alternatives and evaluate according to requirements. Also, you need to gather additional requirements if needed, and use transformations to suggest feasible alternatives. In order to show more detail in the ER diagram, attribute to entity type transformation may be needed. According to the scenario, we have the initial design that reading only include employee number. However, employee number is not directly under the entity type reading. This should be the foreign key from employee. Therefore, the reversed design should learn more about employees' details. Therefore, these employee entity types were added to our new reversed design. Then we will talk about combined attribute transformation. Final level of detail supports improved search because it is more difficult to search adjust because of lack of standardization. Primitive attributes is easier to search about adjust details. Therefore, in the initial design, customer adjust is combined attributes, and in the reversed design, customer adjust was changed to customer fact, customer for, customer broad, customer strict, and customer district. Entity type expansion transformation may be needed when there are some changes in requirements. In this scenario, initially each rate contains a fixed and variable component. However, when multiple tiers of fixed and variable components for each rate are added, rates can be highly complex. Lots of effort may be needed for understanding the requirements and representing correctly. In the common case, identification dependency is not necessarily part of this transformation. But in this situation, identification dependency is reasonable. Weak to strong entity transformation is used for facilitating reference after conversion to a table design. Table design involves a combined primary key for a weak entity. This transformation is useful for associative entity types that are on the one side in other one-to-many relationships. In this scenario, the primary key for the weak entity rate is minimum usage. But this is not unique, and this isn't able to be used to identify the rate unknown. Therefore, we need to transform the weak entity to strong entity. Identification dependency symbols should be removed. The solid line between the two entities should be changed to dotted line, and the diagonal lines in the corners of entities should be removed. To find a suitable primary key, we can use integer data type with database management system generate values. The new primary key for the strong entity rate is rate number. History transformation may be necessary for legal requirements as well as strategic reporting requirements. This transformation can be done for attributes and relationships. When applied to attributes, The transformation is similar to the attribute to entity type transformation. The customer address attribute is replaced with an entity type and a one-to-many relationship. For limit history, a number of attributes can be added. For example, to maintain a history of the current and the more recent customer address, two attributes, customer current address and customer previous address, can be used. When applied to a relationship, this transformation typically involves changing a one-to-many relationship into a many-to-many relationship with an attribute. When applied to a many-to-many relationship, this transformation involves the conversion of the many-to-many relationship into an associative entity type along with the addition of a change date attribute that becomes part of the primary key of the associative entity type. Then generalization hierarchy rule will be introduced. There are the rules for using generalization hierarchy. First, to mimic generalization hierarchy as much as possible, each subtype table contains specific attributes plus the primary key of its parent table. There should be foreign key constraints for subtype tables. Cascade delete option should be available for reference rows. Second, to reduce list for null values. Last, to use joins and outer joins to combine tables. This transformation should be used sparingly because generalization hierarchies are specialized modeling tools. Subtypes have specialized attributes that do not apply to all entity types. The entity can be classified to two entity types. In this scenario, customers can be classified to commercial customers and residential customers. Residential customers don't have taxpayer ID and enterprise zone, while commercial customers don't have subsidized during type. Instances of original customer entity type have null values for specialized attributes. By using generalization hierarchies and classifying the customers into two different types, null values for these attributes can be avoided. This transformation should be used sparingly because generalization hierarchies are specialized modeling tools. Subtypes have specialized attributes that do not apply to all entity types. The entity can be classified into two entity types. In this scenario, customer can be classified to commercial customers and residential customers. Residential customers don't have taxpayer ID and enterprise zone, while commercial customers don't have subsidized during type. Instances of original customer entity type have null values for specialized attributes. By using generalization hierarchies and classifying the customer into two different types, null values for these attributes can be avoided. Therefore, the new ER diagram should be changed like this. This is the summary of transformations you have learned in this lesson. Attribute to entity type transformation replaces attribute with an entity type and a one-to-many relationship. This transformation is used when detail about an entity is needed to add it. Combine attribute splitting transformation replace an attribute with a collection of attributes. It is used for standardizing the data in an attribute. Entity expansion type transformation adds a new entity type and a one-to-many relationship. This transformation is used for adding a finer level of detail about an entity. Weak to strong entity transformation removes identification dependency symbols and possibly add a primary key. This transformation is used for removing combined foreign keys after conversion to tables. History transformation can be classified as attribute history transformation and relationship history transformation. History transformation include attribute history transformation and relationship history transformation. For attribute history transformation, an attribute should be replaced with an entity type and a one-to-many relationship. For relationship history, relationship cardinality should be changed to many with an attribute. This transformation is used when detail for legal requirements or statistical reporting is needed to add. Generalization hierarchy can be started from a supertype or a subtype. When starting from a supertype, subtype and generalization hierarchy is needed to be added, and the attributes to subtype should be redistributed. When starting from subtypes, a supertype and a generalization hierarchy should be added, and common attributes and relationships to the supertype should be redistributed. This transformation should be used when classification of entity is accepted and attributes and relationship for the subtypes is specialized. There is the question for you. How many transformation methods can apply to the following table? That's the end of the lesson.